Hello guys, in the last video we've solved Knapsack problem using brute force approach, in which we try all the possible cases, right? So for this approach, where at each step we have two choices, right? So our time complexity, as you can see in this diagram. So for each step we have two choices, right? Again, we expand again and again recursively. So for every step we always have two choices. So this kind of graph, the time complexity is O2 to the n, which is pretty bad for if the input is large. So in this video, wanna try to improve on the previous video, on the previous approach. So if you haven't watched it yet, come back, and I'll leave the link below. Come back and watch it before watching this video, because this one will base largely on the previous one. So here the code, right? I'm gonna go through the algorithm again, right? So so in order to find the best, to pick the best items that generate the most profit, we try to generalize our problem into these functions, which can be paraphrased as: given the capacity of the knapsack, right? Using these items current index. Current index here is it's just a way to current index here represent for our space, for our input, right? For example, if current space 0, we are considering all the input starting from 0. But if the current index is 2, we're considering only all the elements starting from 2, which is from here, because it's 0 base index 0, 1, 2, 3. So again, we generalize a problem into given capacity and the items. What is the max profit we can get out of it, okay? So from this problem, we're considering each item, right? Starting from the first item, we're considering each item. For each item, we have two choices: either pick it or either skip it, right? So from the original problem, we divide into two sub-problems. Which is in turn can be solved recursively, right? So if we pick the first problem, then our problem becomes with the capacity of original capacity minus the item that we have picked, right? So we eliminate out the item we have picked from our parameter, our input, and given the capacity, and we also update the items because we have picked the first item, so we cannot pick it again. So we also want to increase the current index, right, by 1, so that we considering the next elements. So as you can see from the original problem, we divide into 2 subproblems. For each subproblem, you can again divide into 2 subproblems, and so on. One bad thing about this approach is that we are brute forcing all the possible cases, and a lot of it can be repeated, which is pretty bad for performance. So in this approach, in this video, of course, we based on the previous problem, previous solutions, which is top-down approach, right? But we're trying to somehow catch the result based on the parameter. So whenever we have the result for some input, we want to catch it, so that later when the same functions is called with the same arguments, we just want to take it from the cache, but not recalculate it again, right? One more thing, the reason we call our approach is top-down approach is that we start asking let's think that for every function's goal, it is just a way of us asking a questions given input. So the first question that we've asked is the original questions using the original input, right? So we start from the original input and trying to divide into smaller subproblems, and when we have results for subproblem, like here, we're trying to find we're trying to calculate the maximum profit, right? So that's why we call it top-down approach. We start from the original questions, right? So in order to catch or resolve, you could do something like storing a variable outside, but it's not very clean code, right? And better solution is to encapsulate our logic inside one function only. So in order to do that, probably we need to define a function inside like dfs, because we're trying to recursively call function in depth first search function. So the dfs here, let's call it the same but denote with underscore, which means it's private functions. So as I said earlier, for each function, it's just a way of asking that. It's just asking the questions. So for given capacity, here we don't need to these two parameters, because by closures in JavaScript we have access to these, right? So what is the max profit given this capacity of the knapsack and the current index, which determines how many items, what items are we considering a current index, right? I want it to be the same as the previous from the outside functions, but the reason we are doing like this is because we want to have a closure variable here called catch. So down here I want to move everything inside, right? The logic inside. Right, the function is the same because we want to recursively call the inside, right? So we change the name here and also the number parameter. Right. So down here we return 5 marks. Here is our first questions. Here is our first questions where we start asking questions. The first question is for the capacity, right? For this capacity, and current index is 0 because we are start considering all the elements. So for the catch, yeah. Now let's start with catching part. Let's say probably I want to catch the two parameters So here's the result. I don't want to return it right away, but want to store it in the variable, return it. But before return it, I want to catch it, right? Catch. What is the key here? The key here is these two parameters, capacity and current index. Capacity let's start in an array. Capacity, these combinations combine into a key, right? Current index is result. So after we calculate it, we want to store it in result, and also when we find that key inside the cache, we probably want to, so if this is, if we have something in the cache, we want to return this one. We don't need current index because we passing it here. Okay, let's run it. Just 15.1. Okay, it works. So that's it for this video. Thank you for watching. See you in the next one.